Okay, in this video, let's talk about the section 8.6. Double angle and half angle formulas. In the last section, we know the sum formula and the difference formulas, right? What is the sum formula for sine? Sine alpha plus beta is sine alpha cosine beta plus cosine alpha sine beta. It's a sum formula. And difference, sine alpha minus cosine sine alpha minus beta is sine alpha cosine beta minus cosine alpha sine beta. It's a sum and difference formulas for sine. Cosine alpha beta is cosine alpha cosine beta minus sine alpha sine beta, and cosine alpha minus beta is cosine alpha cosine beta and plus sine alpha sine beta. Be careful about the signs, okay? So especially for cosine the sum has a difference, the difference has a sum. Okay, so these four formulas are very, very important in this trigonometry. And let's see the special case. One, alpha beta are both equal to angle theta. So for alpha equal to beta equal to theta, of course the difference will become 0. Then 0 is not interesting. We'll talk about the sum. Let's talk about sum. So alpha equal to beta equal to theta. So the left hand side, sine alpha plus beta becomes a sine 2 theta. On right hand side, sine alpha is a sine theta. Cosine beta is cosine theta. Cosine alpha is cosine theta. Sine beta is still sine alpha, sine theta. So see the same thing. So it's 2 sine theta cosine theta. So this is the first formula for today. Sine 2 theta is 2 sine theta cosine theta. That's called the double angle formula for sine. The double angle formula for sine. Double have a coefficient 2. And same thing, alpha equal to beta equal to theta. Let's see the cosine 2 theta. Cosine 2 theta, we do the same thing. It's a cosine theta minus sine theta and sine theta. And this is cosine theta square minus sine theta square. So it's our second formula. Cosine 2 theta is equal to cosine theta square minus sine theta square. Alright? Okay. And for the this is not equal to 1. The sum is equal to 1. The difference is not 1. Okay? So be careful. And we know that, yeah, we just mentioned the sum is equal to 1. The sum of a cosine square plus sine square is equal to 1. We move sine square to the right side. We got cosine square is equal to 1 minus sine theta square. Plug in here. Okay, so we get a cosine theta square minus sine theta square. Cosine theta is a 1 minus sine theta square. This is cosine theta, and minus again. So the right hand side is also equal to 1 minus 2 sine theta square. 1 minus 2 sine theta square. Okay? In the same spirit, cosine square plus sine square is equal to 1. Then sine theta square is 1 minus cosine theta square. Then we do the same computation. Then cosine theta square minus sine theta square is equal to cosine theta square minus parenthesis sine this 1 minus cosine theta square. Okay, so it's not, we don't finish it. Minus parenthesis, let's simplify. It's a cosine theta square minus 1 and plus cosine theta square. So cosine theta square is a 2 cosine theta square minus 1. So the right hand side, this is the right hand side. The right hand side can also be written as a 1 minus 2 sine theta square or 2 cosine theta square minus 1. So for the cosine 2 theta, directly from the sum rule, you get cosine theta square minus sine theta square. And by the trigonometric identity, the formula can also be written as a 1 minus 2 sine theta square or 2 cosine theta square minus 1. So the double angle formula for cosine has 3 different expressions. They are all equivalent, but sometimes you use this and sometimes you use that one. Okay, so this is the double angle formula for cosine. The double angle formula for sine is just one formula, one expression. Sine 2 theta is 2 sine theta cosine theta. Okay, sine 2 theta is 2 sine theta cosine theta. And in the textbook, they consider them as 4 formulas, 1, 2, 3, 4. But anyway, it's a double angle formula for the sine. Okay, so let's try to do some example. If sine theta is 3/5, theta is between pi over 2 and pi. Find the exact value of A, sine 2 theta. Okay, so we're looking for sine 2 theta. By the double angle formula, sine 2 theta. By the double angle formula, sine 2 theta is equal to 2 sine theta cosine theta. So we already know the sine theta, but we don't know the cosine theta. So we have to figure out the cosine theta first. Okay, so let's try to compute the cosine theta given the sine theta. Sine theta opposite over hypotenuse. Opposite over hypotenuse, the sine theta. Then by the Pythagorean theorem, a square, you assume this adjacent is a square plus opposite square is equal to hypotenuse square. So a square plus 9 is equal to 25. So a square is 16, so a is 4. So just keep in mind, 3, 4, 5 is a right triangle. So this is 4. Adjacent is 4. Okay? Then the cosine theta is adjacent over hypotenuse. But be careful, this angle is in the second quadrant. Pi over 2 to pi is the second quadrant. Cosine is negative. So it's a negative 4/5. Okay, So this is a cosine theta. Once you get a cosine theta, just plug in the data. So 2 times 3 over 5 times negative 4 over 5 is what? 2 times 3, 6. 6 times 4, 24. Denominator, 5 times 5, 25. It's negative because it's a positive times negative number. Okay? So the answer is negative 24 over 25. That's sine 2 theta. Right? 2 sine theta, cosine theta. Okay? So cosine 2 theta. Cosine 2 theta, if you use the original expression, cosine 2 theta is equal to cosine theta squared minus sine theta squared. If you use the original equation, you have to figure out cosine theta. So you have to repeat this process. I mean, assume you didn't do the first part. You have to do this in order to find the cosine theta equal to negative 4 over 5. And the sine theta is 3 over 5. And then you plug in negative 4 over 5 and squared minus 3 over 5 and squared. And then you compute, it's 16 over 25 minus this is 9 over 25. The difference is 7 over 25. Okay? So this is a cosine 2 theta with the original expression, right? Well, it's not necessary like this because we already do the first part. We know the cosine theta, so we don't feel any difficulty. We don't feel any like additional computation. But if you didn't do the first one, you just directly get this. Possibly this one is easier because the second formula, second expression, 1 minus 2 sine theta squared, you don't do anything. You just plug in the data. Okay, that's the first. That's the first try. So here you don't have to do any triangle, any computation. You just plug in 1 minus 2 times sine theta squared. So 3 over 5 squared. So it's 1 minus 2 times, it's 9 over 25. 2 times 9 over 25 is 1 minus 18 over 25. So it's 7 over 25. The same thing, the same answer, but you see here, you just directly do the computation. You don't have to compute the cosine. So that's the advantage. So especially for the cosine 2 theta, sometimes you choose the proper expression, you will save your time. Okay? Otherwise, you may have to compute some additional values. But it doesn't matter which formula you choose, you will always get the same answer. The answer does not change. All right? Okay, so this is the double angle formula for sine and the cosine. Especially for cosine, there are 3 expressions. After the sine cosine, let's talk about the tangent. The sum rule for tangent, double angle formula comes from the sum formula. So tangent alpha plus beta, recall that it's a tangent alpha plus tangent beta over 1 minus tangent alpha tangent beta. This is the sum formula. And you let alpha equal to beta equal to theta. So we get a tangent 2 theta is equal to the numerator, tangent theta plus tangent theta. So 2 tangent theta over 1 minus tangent theta times tangent theta. Tangent theta square. Okay? 1 minus tangent theta square. By the way, 1 plus tangent theta square is secant theta square. This is 1 minus, so you cannot use it to simplify. Okay? We want to use tangent in the formula. So this is the formula, the double angle formula for the tangent theta. All right? Okay. Let's continue. So sometimes this one, not this one. Sometimes we can continue the multiples of angles. So example. We'll continue the multiples of examples, multiples of angles. So let's talk about the triple angle. The triple angle, what is a triple angle? Okay. Sine 3 theta. Sine 3 theta, let's consider it as a 2 theta plus theta. We still need the sum formula. So it's a sine 2 theta cosine theta plus cosine 2 theta sine theta. Okay? The sum formula for the sine. And sine 2 theta, we know sine 2 theta is a 2 sine theta cosine theta. This is a sine 2 theta. And times cosine theta. Cosine 2 theta, we want, if you don't have any requirement, you can continue it, you can select any formula. But if you want to just use sine to represent the sine, the sine 3 theta, so cosine 2 theta, I'm going to write like 1 minus 2 sine theta square, and then times sine theta. Okay? And here you have cosine theta square. So 2 sine theta cosine theta square. Here you get sine theta minus 2 sine theta cubed. This is cubed. Again, I mean, it depends on your special requirement. Here, cosine theta square. I don't want a cosine, I want a sine. So cosine theta square is a 1 minus sine theta square. Okay, let's continue the computation. So it's a 2 sine theta and 2 minus 2 sine theta cubed and plus sine theta minus 2 sine theta cubed. Combine these two. So you get 3 sine theta minus 4 sine theta cubed. So if we require the answer only involves sine, so this is the answer. If you don't have that requirement, you can leave it like this. It's also the answer. Just because when you have higher power cosine theta square and sine theta square, you can write in a different way. Okay? So that's another example, and this is a sum formula, the double angle formula for the tangent theta. Okay. You can also consider this example, but whatever. We just try to go through the sum formula several times in different way, or we just try to continue the computation, figure out the triple angle formula. But this is not a formula you're required to memorize. It's just a way to tell you how to derive it, right? Okay, so let's recall. Cosine 2 theta is 2 cosine theta squared minus 1 is also equal to 1 minus 2 sine theta squared. For the first one, let's move 1 to the left side. And divide by 2, we get our expression. See, you divide the equation by 2, you get cosine theta squared is equal to 1 plus cosine 2 theta over 2. 1 plus cosine 2 theta over 2. This is cosine theta squared. Why do we consider this as a formula? Because on the left-hand side of the formula, it has a power. On the right-hand side, it has no power, but it has a coefficient 2, the multiple of theta. This formula is very useful when you do the integration of cosine theta squared in the calculus. So you will use this in the calculus. Okay, cosine theta squared is equal to this. We reduce the degree to the lower degree, or to the degree 1. With the degree 1, we can do some special computation. With the power, we cannot do that. Okay, this is a cosine theta squared. If we select the other one, cosine 2 theta is equal to 1 minus sine theta squared. Then we move sine theta 2 sine theta squared. We move 2 sine theta squared to the left side and cosine 2 theta to the right side. And then we divide the equation by 2. We get sine theta squared is equal to 1 minus cosine 2 theta over 2. Cosine is 1 plus cosine 2 theta over 2. All right? Okay, so this is a cosine theta squared equal to this. Sine theta squared is equal to this one. We reduce the degree from 2 to 1. That is the purpose. Okay? Also, this is a formula. And once you know sine theta squared, cosine theta squared, what is a tangent? Tangent theta squared is a sine theta squared over cosine theta squared. So sine 1 minus cosine 2 theta over 2. Cosine 1 plus cosine 2 theta over 2. You multiply top and bottom by 2, you will get, just cancel the common denominator. You will get 1 minus cosine 2 theta over 1 plus cosine 2 theta. Yeah. All right, so this is a tangent square, the tangent square. And even in the textbook, this is the formulas 6, 7, 8. They are labeled by number 6, 7, 8. Those 3 formulas do not have to be memorized since their derivations are so straightforward. But, well, you just do the solution. You just solve it, okay? It's not very bad. Okay. Let's continue this example. we want to know what is cosine theta to 4 to the fourth power. Cosine theta to the fourth power. It's a special example. Well, you can consider it as a cosine theta squared and then squared. Well, first of all, we have to know what is the requirement. The requirement is write cosine x to 4 an equivalent expression. So you're going to basically, you see here, write it in an equivalent. Equivalent means identity. Equivalent expression that does not involve any power of sine or cosine. Greater than 1. Of course, it will contain the power 1 if you have sine cosine, but we don't want to have a big higher power. Okay, so we will continue this. Cosine theta to fourth power is a cosine theta squared and then square, because we know how to apply the square. Cosine theta square. Okay, cosine theta square is where is cosine square? Okay, this way. It is 1 plus cosine 2 theta over 2 and then square. Okay, so we're going to simplify this. We're going to simplify. It's numerator over denominator then squared. So it is a numerator square over denominator square. Over denominator square means the multiplication with the coefficient 1 over the denominator. The numerator square is 1 plus cosine 2 theta square. It's continuous. Okay, so it is equal to 1 over 4, 1 plus 2 cosine 2 theta and plus cosine 2 theta square. Okay, remember that a plus b square is a square plus 2ab plus b square, right? Well, this one has power 1. It's not greater than 1, so this term is already solved. Here 1 is solved. You don't have to do anything about it because it has power 1. We do not want any power greater than 1. This one is okay. The problem is cosine 2 theta. Cosine 2 theta square is again the cosine square. It's again cosine square. Where is cosine square? Yeah. Okay, so let's study this type of a formula. When we say, okay, we get cosine theta square is 1 plus cosine 2 theta over 2. This formula does not only work for theta. It actually works for whatever input here. For example, here we have a cosine 2 theta square. How do you apply this formula? Just consider 2 theta as this theta, and the right hand side you are going to double the left angle. I don't care what the expression of the left angle, you're going to double it. You double the left angle. Left is 2 theta, you double it, you will get 4 theta. 2 times 2 theta. 1, 2 comes from the formula. The other 2 comes from the expression on the left hand side, and then over 2. Okay, so be careful. So actually this formula, you can just consider it as a whatever input. So theta just represents this input. It's a double of whatever you have on the left hand side. If here's 2 theta, this becomes double. It's a 4 theta. If here's 3 theta, then this becomes it's double 6 theta. Okay, the expression totally depend on the left side. Okay. So here 1 plus cosine 4 theta over 2. Okay, so let's continue the simplification. It's 1 over 4. 1 plus 2 cosine 2 theta. Here's 1 over 2 is 1/2, then 1/2 cosine 4 theta. 1 plus 1/2 is 3/2. Okay, so inside the parenthesis you have 3/2. Then we multiply 1 over 4. 3/2 times 1 over 4 is 3 over 8. It's constant. Then 1 over 4 times 2 cosine 2 theta is 1/2 cosine 2 theta. 1 over 4 times 1/2 cosine 4 theta is 1 over 8 cosine 4 theta. So this is the final answer. Okay, it's a final answer. Right, it's very cool. Then let's try to solve an equation. Sine theta times cosine theta is negative 1/2. Theta is between 0 and 2 pi. Last time we solved the sine theta plus cosine theta is equal to 1. This time let's try to solve it equal to negative 1/2. Well, last time is the sum. This one you have sine theta times cosine theta. Whenever you have sine theta times cosine theta, consider the double angle formula for sine 2 theta. Remember that sine 2 theta is 2 sine theta times cosine theta. Sine 2 theta is 2 sine theta times cosine theta. So we multiply this equation by number 2. The left hand side and right hand side both multiplied by number 2. Then you will get 2 sine theta cosine theta is equal to negative 1. And this one you can simplify it as sine 2 theta is equal to negative 1. Okay? So, well, theta is between 0 and 2 pi. Then 2 theta is between 0 and 4 pi. Keep this in mind. It is between 0 and 4 pi so far. Sine of an angle is negative 1. Now what is the meaning? See. This one is 3 pi over 2. This one, this point, the negative 1 point. It corresponds to 3 pi over 2 plus 2 pi. And continue plus 4 pi, continue plus 6 pi. So 2 theta will be 3 pi over 2 or 3 pi over 2 plus 2 pi because it's in the domain 0, 4 pi. If you continue the addition, it will be bigger than 4 pi. If you move to the left, it will be less than 0. Okay, so there are 2 solutions. For 2 theta, remember we discussed 2 theta so far. 2 theta is 3 pi over 2. Then theta divided by 2, you will get theta is 3 pi over 4. 2 theta is 3 pi over 2 plus 2 pi. Then theta is 3 pi over 4 plus pi. You divide everything by 2. It is 7 pi over 4. So theta is still in the domain 0, 2 pi, but 2 theta is in the domain 0, 4 pi. Okay, so the solution set is 3 pi over 4 and 7 pi over 4 are solutions. All right. So whenever you see sine theta times cosine theta, check if you can use a double angle formula for sine. Okay. Let's copy this. Sine theta squared is 1 minus cosine 2 theta over 2. Okay, and cosine theta squared is equal to 1 plus cosine 2 theta over 2. And the tangent theta squared is 1 minus cosine 2 theta over 1 plus cosine 2 theta. So 3 formulas. For those 3 formulas, if you consider this way, you double the left side. Then we can write whatever form on the left side. So for example, we can write left side as theta over 2. If left side, we write it as a theta over 2. You double it. You double the left side, you will get theta. Theta over 2 times a theta. Theta over 2 times 2 is equal to theta. Okay, sine theta over 2 squared is 1 minus cosine theta over 2. Here, the double, this 2 is cancelled with this 1/2. And same thing, you divide 2 on the left hand side. Then this multiplication with 2 cancelled with this denominator. And tangent, it's a theta over 2. Tangent of theta over 2 squared is 1 minus cosine theta. 1 minus 1 plus yeah. And 1 plus cosine theta. So this coefficient 2 is absorbed by the denominator 2. Okay, so these are the so-called well, it's not half angle, but these are the also useful formulas because they involve the half angle. So it's almost the half angle formula, but they have squares. They have square. How do we get a half angle formula? Half angle formula, you are going to take square root. But once you take square root, because you have no idea about the sign, so you have to keep plus minus sign. So the half angle formula is the following thing. Sine theta over 2 is a plus or minus square root of 1 minus cosine theta over 2. Just take square root of all 3 parts. Cosine theta over 2 is a plus or minus square root of 1 plus cosine theta over 2. And tangent theta over 2 is equal to plus or minus square root of 1 minus cosine theta over 1 plus cosine theta. So this is called the half angle formula. and the sine depend on the quadrant of half angle. Plus or minus sine depend on the quadrant of theta over 2 of the angle. Okay? So the half angle formula comes from the double angle formula for cosine, because this formula comes from the double angle formula for cosine 2 theta, and we just manipulate this expression of theta from theta to theta over 2. You get this one, and then we take square root. Okay. So let's try it. For example. Cosine 15 degrees. Last time, after we studied the sum and the difference formulas, we did the following computation. We consider 15 degrees as 45 degrees minus 30 degrees. And this time, let's try to apply this half angle formula. So cosine 15 degrees is cosine 30 degrees over 2. So theta is 30. And 15 is in the first quadrant. It's a positive, so you're going to take a positive square root. And so 1 plus cosine 30 degrees over 2. 1 plus cosine 30 degrees over 2. It's a positive. Cosine 30 degrees, what is cosine 30 degrees? Square root of 3. Right? Square root of 3. So the expression looks like this. And so the cosine 15 degrees is a square root of 1 plus square root of 3 over 2. Let's compute cosine 15 degrees from the difference formula. So cosine 15 degree is a cosine 45 degree minus 30 degrees. So by the formula, it's a cosine 45 degrees cosine 30 degrees plus sine 45 degrees sine 30 degrees. Cosine 45 root 2 over 2, cosine 35 root 3 over 2, plus sine 45 root 2 over 2, sine 30 degree half. So the numerator is root 6 plus root 2 over 4. Well, are they equal to each other? Okay. I don't know. Well, let's check if they equal to each other or not. Well, it's a good question. With the square root, I don't know. They are both positive number. Let's square both sides. I want to square both sides. After I square both sides, possibly I will know it. The difficulty comes from the square root. With the square root, I don't know how to do that. Okay, so I square two sides. Okay, so left side is easy. Square cancelled with the square root. The right side, let's square it. The denominator becomes a 16. The numerator. Numerator is the square root of 6 squared. Again, recall that. Okay, so square root of 6 squared is a 6 plus 2ab, 2 times square root of 12, plus b squared plus 2. 6 plus 2 is 8. Square root of 12 is 2 times square root of 3. It's 3 times 4. You move 4 forward. Outside is 2. So it's 4 square root of 3. 2 times square root of 3 times this 2 is 4 over 16. You cancel 4, you will get 4, 2 plus square root of 3. Okay, so that's a problem. That's why I feel weird. It's totally my problem. As cosine 30 degrees square root of 3 over 2, not square root of 3. Okay, I just don't know. I feel I'm wrong. Okay, cotangent 30 is the square root of 3. This one is a square root of 3 over 2. It's my bad. I don't know how. I just consider this is a cosine 30 degrees. My bad. Okay, so this place is a 1 plus, let me rewrite it. 1 plus square root of 3 over 2, and then whole thing over 2. Okay, now this makes sense now. Okay, so here is a 1 plus square root of 3 over 2 over 2. Here is 1 plus square root of 3 over 2, and then over 2. Take square root, cancel it. So let's simplify this. This one is 1 plus, let me rewrite it in the good way. The numerator becomes 2 plus square root of 2 over 2, and then over 2. So it's 2 plus square root of 2, square root of 3 over 4. See? Okay, finally I got the right one. By this verification, I figure out where I make a stupid mistake here. So this one. Okay, so my bad. It's easy to make this mistake. It's totally my bad. All right, so after we square two sides, we know they equal to each other. When we take a positive square root, they still equal to each other. So these two numbers, they look different, but they actually mean the same thing, same number. So you can leave this as your answer. I mean this. Don't simplify. Don't try to simplify. Leave this as answer, or you can leave this as answer. These two numbers come from two different resources. Good. Okay. Second, let's compute the sine negative 15 degrees. Okay, so this time it is a sine negative 30 degrees over 2. And this is in the fourth quadrant. In the fourth quadrant, the sine is negative. Right? So it's 1 minus cosine double theta. So negative 30 degrees squared over 2. 1 minus how do I get squared? It's so stupid. It's a 1 minus cosine theta over 2. No square, no square, no square. All right? Okay, so negative square root of 1 cosine negative 30. Cosine is an even function. Cosine negative 30 is a cosine 30. Cosine 30 is a square root of 3 over 2. Okay? So this time, it's like this. Don't simplify. Don't simplify. Okay. Okay, good. Let's compute. Let's try another example. For example, if alpha cosine alpha is negative 3 over 4. Alpha is between pi and 3 pi over 2. A. Find sine alpha over 2. B. Find cosine alpha over 2. C. Find tangent alpha over 2. Sine alpha, cosine alpha, tangent alpha. They all depend on the quadrant of alpha over 2. So we have to know the quadrant. Let's check. Alpha is between pi and 3 pi over 2. So pi, divide this by 2. You get alpha over 2 is between pi over 2 and 3 pi over 4. Where is it? Where is this? It's greater than pi over 2. It's not in the second quadrant. It's less than pi over 3 pi over 2. So this is in the quadrant quadrant 3. Check here. Quadrant 1, 0, pi over 2. Quadrant 2, pi over 2 to pi. It's a second. My stupid mistake. And second quadrant. And here, pi, 3 pi over 2. And here, 3 pi over 2 to 2 pi. And it's a second quadrant. Okay, it's a second quadrant. This is positive, this is negative, this is negative. Sine is positive, cosine is negative, tangent is negative. So you're going to apply the formula sine alpha over 2 is a positive square root of 1 minus cosine alpha over 2. Cosine alpha negative 3 over 5. So it's a square root of 1 minus negative 3 over 5 over 2. 1 minus is plus. So 1 plus 3 over 5 over 2. 1 plus 3 over 5 is 8 over 5. 8 over 5 over 2 is 8 over 10. It's a sine alpha. Cosine alpha over 2. Negative, remember this is a negative. 1 plus cosine alpha and then over 2. It is a negative square root of 1 plus a negative 3 over 5 over 2. Plus, so it's 1 minus 3 over 5. 1 minus 3 over 5 is 2 over 5. 2 over 5 over 2 is 1 over 5. It's cosine alpha over 2. Tangent alpha over 2. You already have this one and this one. Just do the ratio. Or you just recall the formula. 1 minus cosine alpha. 1 plus cosine alpha. 1 minus negative 3 over 5. 1 plus negative 3 over 5. So numerator is 8 over 5. Denominator is 2 over 5. Right? It's equal to negative 2. Okay? So how do I get negative 2? You move this 4 outside, it will be 2. You do the ratio, it's negative 2. Okay? Okay, so there's one more formula. I don't want to write it in a hurry. So there's one more formula about the tangent alpha over 2. What is the formula tangent alpha over 2? I will discuss this formula in the next video quickly, and then we will complete this section. So next video we will start to discuss a tangent alpha over 2 in the different formula, and then we will we will discuss the next section. Okay, so we almost finished the section 8.6 double angle and half angle formulas. This section contains so many formulas. Do practice, try to memorize them. Memorize the formula. They are very, very, very important. Okay, send me email if you have questions. I'll stop this. Thanks.